Hello students, welcome to today's class on artificial neural networks. Today we'll be discussing about the naive-based classifier again. I will explain one more exercise which makes use of naive-based classifier for solving the pattern classification problem. Okay, so to solve this problem, everyone must have watched. I assume that everyone must have watched the previous video, which is on naive-based classification theory. In our previous lecture, we have discussed about what is meant by pattern classification, and also we saw how naive-based classifier can be used for solving pattern classification problems. We discussed two example problems also in our previous lecture. So if anybody has not watched that video, so you first go through that video first, understand how naive-based classifier can be used for solving pattern classification problem, and practice the exercise given over there. Then come back to this video and watch it. Okay. So I request all of you, if anybody has not watched the previous video, that is second video of unit 3, so please watch that video first and then watch this video as a continuous topic of a previous video. Okay. Now let us see the exercise that we want to discuss today. So this is the exercise given in the previous lecture. I asked you to solve this problem in your own. So I hope you tried this, and if anybody has got the answer, it's well and good. Otherwise, I'll explain how to solve this problem now. This problem contains three features: type of family structure, age group, income status. Given as type of family structure has different values such as nuclear, extended, childless, single parent, and also age group is either young or old or middle aged, and income status is either low or medium or high. Based on these features, it is classified into one of the two categories: whether they can buy a car or not. The answer will be either yes or no. So there are two output categorizations here: yes or no, will they buy a car or not, based on the given three features. Uh, that is type of family structure, age group, and income status. So we need to design a naive-based classifier based on these evidences, the available data. Then the corresponding classifier must be able to identify the output of any given input pattern with three given features. Okay. So the task of this problem is to design a naive-based classifier with these evidences, with these input patterns, and then the task is, given the features single parent, young and low. Okay, single parent, young and low. It is actually not available here. Okay, so for this set of input features, you need to predict the probability of whether they can buy a car or not. So the answer may be either yes or no. Okay, so uh, to solve this problem, what you need to do is, there are four steps in naive-based classifier design part. The first step is, you need to compute the prior probabilities of the output labels. Okay, prior probabilities of output labels means how many output labels are there? There are two output labels, that is either yes or no. Okay, so the prior probabilities always calculates the categorical outputs, the probability of categorical outputs. So total number of samples given is 10, out of which probability of yes is 1, 2, 3, 4, 5, 6. 6 yes are there. Therefore, the probability of yes is going to be 6 by 10. These are total number of samples given, and there are 6 yes available in the given input pattern. Similarly, remaining 4 are going to be no, and the probability of no is going to be 4 by 10. Okay, so this is our first step. We need to compute the prior probabilities of the output labels yes or no. Okay, so in the given data, there is no count given over here, so you need to count the labels over in the given problem. So counting is your extra task. Count the number of yes and number of no's out of the total number of samples. Right. And the second step is, once the prior probabilities are available, second step is compute the probability of evidence for each feature given, and this will go into the denominator of the actual calculation based on the naive Bayes classification rule. Okay, so how many features are given? So what are the features given over here? The features are single parent, young, and low. Okay. Single parent, young, and low are the given features. So for those features, calculate the probability of evidence for each feature individually. The probability of single parent is going to be, out of 10 samples, how many single parent classes are there? There are two, 1 and 2. So 2 by 10 is the probability. And probability of young is going to be, out of 10 samples, 1, 2, and 3. 3 out of 10. That means 3 by 10 is the probability of young. And probability of low is going to be 5 by 10. You can calculate it. 1, 2, 3, 4, and 5. CD. Number of lows in income status, it is 5 out of the given 10 samples. Okay, so 5 by 10. So this is the probability of evidence for each input feature given. And the denominator is always going to be probability of these three features combined, that is probability of single parent, young, and low, which will be calculated as a product of probability of single parent into probability of young into probability of low. That is 2 by 10 into 3 by 10 into 5 by 10. That gives us a value 0.03. Okay. So this is the probability of evidence that goes into denominator of naive-Bayes classifier rule. So once the first two steps are completed, the next thing is we need to calculate the probability of likelihood of evidence for each class of output. There are two classes of outputs given in our problem, as we know. It is yes or no. So for each class of output, yes or no, we need to calculate the probability of likelihood of evidence for the given set of features, that is single parent, young, and low. So first we'll start with the probability of single parent, young, and low given yes feature, given yes categorical output. Okay. So the formula for this is probability of single parent given yes into probability of young given yes into probability of low given yes. So how do we calculate these values? Probability of single parent given yes, you need to count it from the table. Single parent with a yes combination, there is only one combination. The other one is single parent no. Therefore, single parent yes is going to be only one out of 6 yes. Okay, out of 6 yes. So we are calculating for yes here. Therefore, 1 by 6 it is. Similarly, probability of young given yes is going to be, here it is 1, 2, so only 2. Young given yes is 2 options out of 6 into probability of low given yes is again 1 by 6 from the table. You can see it from the table. There is only one low with yes. See, one low with yes, and all the remaining lows are with no's. Therefore, we'll take it as 1 by 6. Okay. So this gives us 1 by 6 into 2 by 6 into 1 by 6, and the value is 0.00925. Similarly, we will calculate the probability of likelihood of evidence for the class of output no. P of single parent comma young and low given no. The probability of single parent given no into probability of young given no into probability of low given no. You can get the values from the table. So this we can calculate using the formula. Probability of single parent young and low given no is equals to probability of single parent given no into probability of young given no into probability of low given no. So which can be identified from the table. Probability of single parent no combination. We need to identify probability of single parent no combination is 1. The count is 1 out of 4 no's. The categorical outputs are no, 4 for no, therefore 1 by 4, 1 out of 4 into probability of n given no also you can identify it from the table. N with no is only 1 out of 4 no's, therefore it is also 1 by 4. And probability of low given no is 4 by 4. You can see whenever no is there, it is always going to be low. 3 and this one is 4. 4 no's out of 4 no's. Okay. So it is 4 by 4. So together the value becomes 1 by 4 into 1 by 4 into 4 by 4. That gives us 0.0625. Okay. So this is the crucial step, calculating the probability of likelihood of evidence for each class of output. Once we calculate this and we are ready to predict the class of output for the given features, single parent, young and low, with the help of naive-Bayes classifier rule. Okay. The formula for naive-Bayes classifier rule is probability of yes given these features. Okay, and probability of yes given these features is equals to, the formula is probability of the given features given yes and into probability of yes by probability of single parent comma young and low. So we have already calculated this one. Probability of single parent comma young and low given yes is 0.00925 into probability of yes also we have calculated is in our first step. Probability of yes is 6 by 10, that is 0.6. So 0.00925 into 0.6 by this we have calculated in our previous step. Probability of evidence, it is 0.03. Okay. So this gives us, when we evaluate, it is 0.185. Similarly, we will calculate probability of no given the feature single parent comma young and low with formula probability of single parent comma young and low given no into probability of no. So again we are going to multiply 0.0625. This we calculated here, 0.0625 into probability of no, which we calculated in first step. It is 4 by 10, that is 0.4. 0.4 by 0.03. So this gives us 0.833. So if you observe the probabilities of categorical outputs for yes is only 0.185, whereas the probability of no is 0.833. So which one is greater here? Which one is bigger? The probability of no. That means they cannot buy a car. So because the probability of no is more compared to probability of yes, the prediction is they will not buy the car. They will not be able to buy the car with the given input features, single parent, young and low, right? So that is how you solve the pattern classification problems with naive-Bayes classifier. All of you practice this again to understand it properly, right? Here is one more problem for your practice. It's given 10 samples again. There are three features given: color, type, and origin. Color are either red or yellow. Type may be either sports or SUV. And origin is either from domestic or imported. Okay, there are two classes over here. And whether the car can be stolen if with these input features are also given, either yes or no. So this problem is similar to the previous problem that we solved. So given these input samples, you are required to predict the given features. Red SUV and domestic. It is not available here. Red SUV and domestic. Will the car be stolen? You need to answer it with either yes or no. So calculate this the given input samples. Okay, so practice this problem and come up with the solution. If anybody is not able to answer this, you can contact me over phone. So that is about naive-Bayes classifier, and there is one more thing we need to define. Actually, we have gone through the perceptron convergence algorithm at the beginning itself. So this is perceptron convergence theorem, which we used in our perceptron learning. If the samples are linearly separable, then the perceptron algorithm finds a separating hyperplane in finite steps, as we saw in our examples. So please watch that first video of Unit 3 to understand how the perceptron convergence algorithm, perceptron converges with the help of perceptron learning algorithm. The rule is if the input patterns are linearly separable, then only we can solve it in steps. Okay. And it also specifies that the running time does not depend on the sample size n. Okay, so somehow it always converges if the inputs are linearly separable. So that is the perceptron convergence theorem says. Actually, there is a proof for this also, and we don't have it in our syllabus. So I'm just mentioning the theorem over here. We don't need to learn that proof for this theorem. And coming to this last topic, advantages and disadvantages of perceptron learning. There are few advantages with perceptron learning. The first advantage is it's very easy to set up and train because it is the simplest form of artificial neural network. And the second advantage is the neural network can be explicitly linked to statistical models, which means the model can be used to share the function, that is covariance Gaussian density function, across the statistical models. The third advantage we have is the single layer perceptron outputs a function which is a sigmoid, and the sigmoid function can easily be linked to the posterior probabilities, as we saw in the given example. And the fourth advantage is we can interpret and input and output, as well as uh, the outputs are weighted sum of inputs. That means we can interpret the input and output as well. Since the outputs are weighted sum of inputs, it is very easy to calculate the outputs from the neural, as it is simply a calculation of weighted sum, which will be given to an activation function to get the final output of a neuron. Okay, so it is very easy to calculate the outputs from perceptron. These are the advantages. Overall, the main advantage with perceptron is it's very easy to set up and train and predict. And the disadvantages are it can represent only a limited set of functions. So that means it cannot solve the range of problems that will be solved by the perceptron neural network is very limited. The second one is the decision boundaries are the treated as the threshold boundaries, which allows only the hyperplanes. Okay, so because of this reason, the perceptron model only works for linearly separable data. It will not work for linearly uh, inseparable data, right? So we know that we can identify whether the input data is linearly separable or not by taking a hyperplane and then drawing some straight line to separate the given input features, right? So if the input data is linearly separable, then we can always design uh, the perceptron learning network, right? So that's all for today. So we have completed the third unit. It's a very small unit. You need to practice only what is a perceptron, the structure of perceptron, and the learning rule used in perceptron, and then what is how a perceptron neural network converges for a given input data. So this is available with the first video, and then the second topic you need to practice is what is meant by pattern classification and how naive Bayes algorithm is used for pattern classification problems. This is available in second video and third video. Okay, so I hope you understood these topics well, and I request all of you again to go back uh, and listen, watch the videos from the beginning, and practice well. Thank you all. In our next class, from our next class, we'll start revising the topics that we have discussed till now. Again, I begin from the first unit. Okay. Thank you all for your patient listening. See you in the next lecture.